Su-47 Berkut, a 1,500-word Vice-style feature. There is something unnerving about aircraft that look like they were sketched by someone who thought aerodynamics ought to be illegal. The Su-47 Berkut is one of those machines. A gleaming, forward-swept winged oddity that seems to slice the future in half and then ask whether Tuesday will do. To walk around the prototype at an air show, to feel the metallurgy of its wings, the jut of its twin tails, the almost comic book boldness of its nose, is to confront a paradox. The Su-47 is at once an engineering dare, a technological detour, and a museum piece that never quite made it into the mainstream. But its story is not an artifact of failure. It's a story about ambition, limits, and the stubbornness of ideas. In the late 1980s and through the 1990s, Sukhoi's design bureau in Russia was a crucible of audacity. Emerging from the Soviet era into a period of economic chaos, designers clung to visions of air combat that would make Cold War dogfighters blush. The Su-47 began life as S-37, an experimental platform intended to test a series of radical aerodynamic concepts. Chief among them was the forward-swept wing, a configuration that turns conventional aeronautical wisdom on its head. Unlike the swept-back wings common on most fighters, forward-swept wings angle toward the nose. They promise superb maneuverability, excellent lift distribution, and delayed stall at high angles of attack. They also bring the engineer's nightmare: aeroelastic divergence, where the wing twists and bends under load in ways that can amplify forces and lead to structural failure. To build a forward-swept wing fighter required materials and thinking Moscow had only recently begun to master. Composite materials, light, stiff, and anisotropic, became the answer. Composites allowed designers to tailor the stiffness of the wing so that under aerodynamic loads the structure twists in a controlled, helpful way instead of catastrophically. The Su-47 was an audacious experiment in marrying novel aerodynamics with materials science. The wings were not only forward-swept, they were constructed using advanced composites and unique internal geometries to resist the destructive twisting that had doomed earlier attempts at this layout. The Su-47's silhouette is unmistakable. The long, knife-edged forward-swept wings give it a waspish profile. Its canards, small forewings near the nose, and twin vertical tails hint at the influence of stealth and control augmentation thinking. The intakes are reminiscent of Sukhoi's other fighters, but the whole composition, elongated, narrow, slightly menacing, makes you feel like you're looking at a thought experiment someone decided to take seriously. Inside, the cockpit is compact, with the ergonomics of a testbed rather than a production fighter. Systems aboard were intended for evaluation, not battlefield durability, a flying laboratory. Performance figures for the Su-47 were, on paper, intriguing: exceptional pitch agility, rapid roll rates, excellent control at high angles of attack. Pilots who flew the prototype reported a machine that could perform maneuvers other fighters could only dream of. The forward-swept wings generate strong vortices that cling to the wing surfaces at extreme angles, maintaining lift where conventional designs would stall. That means the Su-47, in skilled hands, could pull tighter turns at lower speeds and execute post-stall maneuvers with more authority. For air-to-air combat, where split-second orientation changes can be life and death, those advantages are magnetic. Yet advantages are always traded for compromises. Forward-swept wings produce structural stresses concentrated at the wing root that demand heavier or more exotic construction to counteract. The Su-47, despite its composite skins, was not a lightweight. Maintenance complexity rose with the exotic materials and bespoke components. Its unique layout also complicated radar cross-section reduction efforts. While not a stealth aircraft in the sense of the F-22 or F-35, the Su-47's shape presented both benefits and liabilities for signature management. And then there is cost in a Russia that, through the 1990s and 2000s, had to prioritize what to fund. A high-cost experimental program competing with operational fighters and nuclear programs faced hard choices. Part of the Su-47's destiny was also geopolitical. It was conceived in an era when Soviet engineers could take wild swings at design. After the Soviet collapse, the Russian defense industry's priorities shifted toward survivability, exportability, and platforms that could be produced and maintained economically. The Su-47 was a prototype. Prototypes, by definition, test ideas. Even if the S-37 Berkut had proven every concept in the book, the leap from demonstrator to serial production, especially in the dire Russian financial climate of the 1990s, would have been gargantuan. But cancelled or limited are not synonyms for irrelevant. The Su-47's real legacy lies in what it taught designers. The knowledge gleaned from its flights fed into the development of subsequent Russian fighters, not by producing a direct copy, but by informing control law design, composite usage, and aerodynamic tricks that could be married to stealth and conventional layouts. In engineering, tests that fail sometimes provide more useful data than those that succeed. The Berkut was a trove of lessons about maneuverability, materials behavior under repeated stress, and the trade-offs between radical airframes and operational realities. There's also the human element. For pilots and engineers who worked on the Su-47, the program was a rare oxygen-rich zone of creative freedom. Engineers could test ideas that would have been bureaucratically strangled in other contexts. Test pilots remember the exhilaration of flying something so unorthodox. The aircraft demanded a blend of respect and improvisation. For them, the Berkut was less a financial gamble and more an expression of what aviation culture at Sukhoi still valued: daring. Then there is the theater of public perception. The Su-47 occasionally made carefully staged appearances, enough to feed the myth machine. Images of its razor wings splashed across defense magazines and websites, inspiring both awe and speculation. Western analysts alternately admired the audacity and questioned the practicality. For many, the Berkut became shorthand for Russian innovation that was brilliant, underfunded, and divorced from the necessities of mass production. That narrative is half true. The Su-47 was brilliant. It was also a product of a system in transition. The aircraft's